Hello students. So let's try to solve one very interesting problem from IIT-JAM 2023. And I think this is question number 25. And this is basically MCQ 2-mark question. And this question belongs to fluid mechanics. So it's a wonderful question. A lot of us didn't do some fundamental mistake into this particular question. But if you will see that this question is really very conceptual. So what is this question? So there is a water tank, and in this tank there is water. So we have row of water is 1000 kg per meter cube. So we know all this thing. And at the bottom, so there is a small hole, and from there water is just going down. But this height, the height from the hole and the surface of Earth is just a 0.01 meter. And from this hole, this particular water is just coming out with the constant velocity 5 meter per second, and this is just coming vertically downward. So what we have to do, we have to just calculate the pressure exerted by water on a surface, and this particular Earth surface. And it is also given when particle will come down and then it will just go horizontally. So it will just come down vertically and after then spread out horizontally. So let's see how we can just approach this problem. So what we have to do, we have to first calculate the mass, and we can just assume that dm mass is coming in time dt. So this dm upon dt, and that is rate of mass flow or mass flow, you can say, that is given by rho into area into V. How you can calculate? Because we know that dm is equal to rho area into dx, and dm upon dt is all about this dt. So this is your rate of flow of mass. So once we will calculate the rate of flow of mass, then we can find the rate of flow of momentum. So that is dp upon dt is equal to force, and when we will multiply it by basically a velocity, then we will get dp upon dt, which is nothing but force. So this is rho into area into v into v. So that value is equal to rho area into v square. And we have to calculate pressure, and we all know that pressure is nothing but force per unit area. So pressure is equal to force per unit area, and that value is equal to rho into v square. And this v is the velocity of water at when it is just going to touch the surface. So we can easily use kinematics, and when we are using the kinematics, then v square is equal to u square plus 2gh. Here u is given 5 meter per second, so that is 25 plus 2 into 9.8 into h is 0.1. So if we will calculate, we can just, this will be approximately 27. So this v square is 27 meter per second whole square, something like this. And now we have to find the pressure in term of kilonewton per meter square. So this thing is given by 1000 into v square is nothing but 27. So this will be 27 kilonewton per meter square. So this will be your answer. So a lot of people have done wrong calculation into this particular problem. They just use the basically Bernoulli's theorem or some conservation of energy part. But here you have to just use the basically the rate of change of flow of mass such that you can find the force, and force per unit area is nothing but pressure. So this is your answer. Thank you.